Welcome to HoloBio, the open source interface for digital holographic microscopy. Here on the main menu you can pick real-time for live acquisition or offline for post-processing and use either lens-based DLHM or lensless DLHM. In this video we use the DLHM package in the offline model. The package has three areas: on the left the parameter controls, on the right the visualization windows, and above them the toolbar. We will learn the basics of the model and how to use the three reconstruction algorithms. So first, load the data, go to the toolbar and click Load. Here you can load a hologram, and you can also load a reference hologram or remove the reference hologram if you want to go back to a non-reference workflow. For our first example, we will reconstruct by angular spectrum without any reference, so we load just the hologram. We set the hologram reconstruction parameters, a wavelength of 532 nanometers and a pixel size of 1.85 micrometers. Here in the unit section, you can set the distance units, so as we can see the unit you select will be the unit of the distance L, C and R, which is L minus C. If you check fix R, you look the reconstruction distance R. With R fixed, when you move L, C moves too, so R stays the same. And with R not fixed, changing L or C will change R. Here the magnification also updates automatically when L or C changes. For this first hologram I use L equal 10 millimeters and C equal 2 millimeters. I select angular spectrum and click reconstruction. And now you can see the phase and amplitude. Use zoom to inspect the tiles. Right-click to return to the full image. In the amplitude view, you can switch between amplitude or intensity. And for the Fourier transform, you can turn log scale on or off. And the last section of the parameter controls allows you to set the minimum and maximum limits for L, C and R sliders. Enter your limits and click Set All. When you change distance, the phase and amplitude images update live. Okay, next let's try a different hologram with the realistic angular spectrum model. So we load the new hologram. We set the wavelength to 532 nanometers, the pixel size to 1.85 micrometers, and and set L to 11 millimeters and C to 4 millimeters and click reconstruction. Again, you can use the zoom switch between amplitude or intensity and enable or disable the logarithmic scale in the Fourier view to explore the result. Now for our last example, we will do a reference-based reconstruction with the Creuser method. So we load the hologram and also load its reference. For this dataset, we set the wavelength to 532 nanometers and the pixel size to 6.9 micrometers. And L to 20 millimeters, and each structure focuses at different C. So the middle structure focuses at a distance of 6.8 millimeters. So we can set this distance and click on reconstruction. And the burn structure focuses at distance of 5.6 millimeters. So again, we can set this distance. And the top structure focuses at distance of 2.8 millimeters. Again, we set the distance. We can also move C to bring each one into focus and verify in both phase and amplitude. And that is the basic workflow. We load holograms, adjust L, C, and R, and run angular spectrum or realistic angular spectrum or Creuser reconstructions. Use zoom, switch between amplitude and intensity, and enable or disable the logarithmic scale in the Fourier view to explore the result. This concludes this tutorial. Thank you for watching.